All right, let's get started. I think we're good to go. Yes, 10:11. All right, thanks for coming to this session. I just asked my Copilot what I'm supposed to do today. And I think it correctly said that I'm scheduled for some speaking activities along with some colleagues of mine, Chris and Cecilia and Alan, whom you might see yesterday doing some sessions. Cecilia is actually part of organizing the conference. And so that's a good start for my Copilot. It seems to be working. So, welcome again. My name is Jakob Ehn. I'm working at Active Solution up in Stockholm as a consultant, working a lot with, among other things, AI, generative AI, and Semantic Kernel. So this talk will be about Semantic Kernel and how you can use that to build your own agents and copilots. I'm going to explain those terms for you right about now. So this is the AI enhanced version of myself that I prefer nowadays. I'm going to keep it forever because things change over time with the physical appearance. So let's just define some terms here when talking about AI assistants. And this pretty much reflects what we have been doing for some time now, since generative AI became popular. So from the left, we started building like simple chatbots. In the beginning, a lot of our customers wanted pretty much their own ChatGPT. They wanted like the hosting their own chatbot using some model. So we helped the customers roll out their own kind of ChatGPT within their organization. The next step was RAG. How many of you have heard the term RAG? All right, excellent. So that stands for Retrieval Augmented Generation, which pretty much means I want to use these models against my own data. How do I do that? Well, you need a system that will fetch that data for you and then feed that to the model. So that's a RAG solution. So we also have, been building a lot of those solutions, chatting with internal data, internal documents, and so forth. And the next step has been this Copilot, so agents or application that sits alongside the user and pretty much helps them with their daily tasks. The idea of a Copilot is that it should not be like an autopilot. It shouldn't do things, on your behalf automatically. Instead, it should help you, guide you along the way, maybe ask for, approval and so on, with, what you want to do. And the last step here is when things become fully autonomous, and that's typically what you call agents, even though that term is used in a lot of ways. But what you typically mean by an agent is kind of the same thing as a Copilot, but it will act. It can be triggered from events in the real world and perform actions by its own. So it's kind of the trend here is from easy to hard, and you really need to learn a lot about these models and how you build applications on top of them before you go in this direction. So Copilot. Everybody talks about Copilot, and Microsoft. This is a statement from Satya from I don't know if it's Build or Ignite. It says we are now the Copilot company, and that's like a technology that has been around for 1 year or something like that. So they're kind of investing heavily in Copilots, and obviously they are throwing Copilots on top of everything. So you have Copilot in Windows, you have Copilot in 365, you have Copilot in Azure, in Dynamics, and so on and so on. So everybody should have Copilots. So you're probably sick of hearing about Copilots, and then obviously you have the GitHub Copilot, which has been around for a while, and then you have just Copilot, which used to be the Bing enterprise thing, which is now just called Copilot. So it's everywhere. So I'd just like to explain, what is a Copilot then in terms of when you're building an application. What do we mean by a Copilot? So I like to explain it in a very simple way. If you think about like the traditional way that we're designing and building software applications, we talk to the users, we figure out a couple of user stories, what they want to do. And then we typically build some kind of UI, to implement that. So maybe you want to create an order, you want to search for products, yada yada. We build some logic, that will do something, maybe call an API. And then the next requirement could be some other UI, and so on, so forth. Like this is the traditional way of building applications. So with the Copilot, we're kind of flipping these things around. So instead of building a lot of UIs, we're kind of relying on this, chat interface, or it could be a voice interface as well. And instead of building or designing all these various user stories, trying to come up exactly with what the user wants, we are now using the kind of the AI in the middle here to be the orchestrator and figuring out what do I need to do in order to fulfill the request of the user. And then still, to actually do something, we need to still be able to talk to these things, typically within the organization or out on the internet. So we still need to be able to call APIs, fetch data from a document store, and so forth. So in order to do that, we need some kind of plugins that the AI can call, and will fetch some data or do something, return the information back to the AI. Maybe the AI will do some other calls and so forth. So in this very simple way, this is what you could call a copilot, and it's now very common, that you expose this chat-based interface. So if you have been developing with large language models, how many here have been doing development with like GPT models? Not so many. But when you do start with the models, the API by itself is very, very simple. It's probably one of the simplest interfaces. The API is just pretty much just one call. You feed it some string, and you get a string back in a very simple explanation. But as it turns out, there's a lot of challenges behind this to actually make the models work, and how you integrate this with the rest of the application. So for starters, there's actually not just one model. There's not just one GPT model. There's a lot of models, and there's a lot of other models as well. It's not just the models from OpenAI. So there's a lot of models, a lot of versions that you need to keep up with. And then you need to deal with things like the context we talked about. It needs to get the proper data in and maybe fetch data on demand. You need to keep track of the chat history if you're building a chatbot, because the history really contains the context to be able to answer, or ask follow-up questions. In order to do that, you need the history. And you need to deal with problems like hallucinations and a lot of other problems as well, actually, with these large language models. So you need some help there. And also you need to be able to, to fetch external data, as I talked about. And really finding a way to, how can you combine the power of large language models with the rest of your applications, because as it turns out, you shouldn't, do everything with the large language models. They're really good at some things, but they really suck at other things. And those things you still want to implement, like you do today in your regular applications. So you need to kind of mix and match here. And this is really the idea with a framework like semantic kernels. There are other frameworks out there for doing LLM orchestrations, but semantic kernel is an open source AI orchestration library from Microsoft. And originally it was just supported .NET. Now they actually have implemented feature parity as well in Python and Java. So it's going to be interesting to see if that part will keep up. There's a lot of other options out there for the Python community in particular. But for .NET, it's really been like this new world when you come to AI and large language models. Like the whole community seems to be around Python. So having this framework on .NET properly implemented is a big gain for us .NET developers. So again, the idea is to be able to mix or combine the language models with your C# application, for example. And it's extensible by implementing your own plugins. So the plugins, and I'll get back to that, is where your code will be running and actually do things. And originally this was actually part of Microsoft's own Copilot architecture, and then they kind of open sourced it and it went into its own direction. But in general, the Copilot that Microsoft are building, they have this AI orchestration layer in the middle where this actually started out. So semantic kernel is the big part here is the kernel itself. So that is what you'll be creating in code, and you'll be connecting it to various things. So for example, you'll be able to integrate with various AI services, for example, with Azure OpenAI or the OpenAI API itself, or Hugging Face and so on. So various models there. It has things like prompt templates. It has things like telemetry monitoring and so on. So basically, you're creating this kernel, and you're filling it up with the things you need, and then you can use it for your, for example, for your chat implementation. So I'll show you several examples very soon. Actually, now. So I was just thinking, let's just start with a few demos, so you know what it looks like. So I'm gonna. Can you see back there? Is it okay with the light background? Otherwise, shout. So I'm just using notebooks here because it's a really easy way of showing code without having a full project. So if you haven't used notebooks in VS Code for .NET, try it out. It's really nice for these kind of things, or sharing code snippets. So I'm just going to show you first like a hello world code using Semantic Kernel. So I'm just going to run this first, and while it's running, I'm just going to explain it. So first up, what you need, you need the the Semantic Kernel NuGet package. That's step one. And then pretty much the only thing you need to do is to do this. So you're creating your kernel, then you're adding various things. In this case, I'm saying I want to use the Azure OpenAI API. So I call the add Azure OpenAI chat completion method. I'm just passing it, which model do I want to use, and some authentication options. So the next line that's commented out is the same thing, but in that case, I would go to the OpenAI APIs instead. And then I'm just building the kernel, and once I do that, it's good to go. So now that I have the kernel, I can use it. So I'm going to just run it and ask it to write a funny joke. It's probably not going to be funny, but it's just like 2 lines of code really. I'm just passing it some parameters, specifying things like how many tokens do I want you to use, what's the temperature, which kind of signals how creative the model should be. And then we get some joke back. So why don't scientists trust atoms? Because they make up everything. And it's fun actually, because I realized when we did this demo for a few times, it kind of came up with the same list of jokes all the time. So I actually had to search for that, and I actually found a link that said that researchers have found that the ChatGPT prefers repeating 25 jokes over and over again, which actually, that's what I also discovered. I'm not sure if those are the best 25 jokes, but then I realized I probably only know like 6 or 7 jokes on top of my head, so 25 is still pretty good. But again, so this is really like the basics. So it's super simple. Just create the kernel, and then invoke the prompt, and then you get the response back, and you're good to go. So then you have some more advanced things, like for example what they call prompt templates. So prompt is really the main thing here. This is what you'll be working a lot when you're working with large language models, because writing a good prompt is actually quite hard, and you're probably going to do this a lot of times. And you probably want to reuse them and also templatize them, so you can send the various parameters into it. So in this case, I can do something like this, write a funny joke about, and then you can refer a variable like this, or a parameter. So the parameter is topic, and then I can invoke 2 prompts here, and then pass the topic food or the topic consultants. So if I run this, I should get 2 jokes. The first one should be about food, and the other one should be about consultants. So again, this is really powerful, because those prompts, you're going to store them somewhere, you're going to want to reuse them. Once they work the way you want to, you're going to want to be using them in many places, or probably also many projects. So it makes sense not to hard code them that way. Another thing that is nice and also quite important is the ability to actually use multiple models within the same program. So in this case, I'm calling the same method here 2 times. I'm adding first the GPT 3.5 model, and I'm adding the GPT 4.0 model. So obviously the 4.0, that's the latest one. It's really powerful and so on. But the 3.5 is also very competent, and it's also cheaper and a bit faster still. And in general, you want to make sure that, because what you're paying for here is the tokens, and you're also talking about the speed of these models. So for some tasks, it can very well make sense to actually use some of the cheaper models and the faster models, and use the more competent models for the more complex tasks. And maybe you heard that OpenAI just released another version called the 0.1 preview, which is like trained on more complex tasks. So it will be slower, but it will be more powerful in the sense that it can solve more complex problems. Again, that will be very suitable for some tasks, but not for all tasks. So by using this, by adding multiple models to the kernel, I can now call it 2 times. First, and the first time I will tell it use this model, and the other one use that model. So in this case, I'm saying write a funny joke in 10 words, and each word should start with the letters A, B, C, and so on. And this was actually one of the cases when they released the GPT-4. That was one of the examples where GPT-4 was better than GPT 3.5. And since then, 3.5 has been better as well. But typically, the 3.5 doesn't really always handle this case. In this case, it was pretty good, actually. A, B, C, D, E, F, G, H. It's pretty good, actually, this time. But sometimes 3.5 doesn't really handle this case, while the GPT-4 actually does handle it. But again, it's really easy now to mix and match these models. And finally, if you want, it also has Semantic Kernel also really built for you to make it easy to write chatbots, chat-based interfaces. So it has this, the interfaces and classes to make that really easy. So let's just run this one. And so it has classes like chat history, which keeps tracks of the history, obviously, because that will be needed every time you ask a follow-up question. And then you can use the iChat completion interface. So this is really, like this while loop here is really all you need to do to actually implement a chatbot that you can keep talking to. So you're going to send it the input from the user, get send the history plus the question, get the response back, add it to the history, and then repeat. So if I run this within a notebook, if you're asking a user for input in this notebook, it will actually show up here. So if it says now, hi, can I help you? I don't know. Who are you? There. It's the user, and the assistant replies back. Okay. Help me write code. Okay. So that's really the basic of those few lines of code. It's really all you need to actually implement a chat-based interface together with the history. So it's really, really simple in that sense. So that's the basics, and it's really a well-written framework that really follows all the standard conventions in the .NET application. So, like hooking up to a web application, it's really, really easy. It has all the dependency injection that you need. So it's very easy to get started if you're a used .NET developer. So if you zoom out a bit, like the 3 main parts of semantic kernels are plugins, planners, and personas. So let me talk about those for a while. So plugins, this is like the fundamental building block. This is where your code will be written or like be located. And the plugins can actually be both prompt-based or native. So prompt-based, then you will pretty much just store your prompt, like the text code. Because again, if you have a well-written prompt, you probably want to reuse that many times. But it can also be native, which means it can be written in C# or Python. And in that case, you're free to do anything you want. So it will be much more powerful, obviously. So you have those options, and another option is actually also if you have existing OpenAPI, endpoints, that complies with the OpenAI API specification. You can actually import them automatically and have them exist as plugins, which means you can actually call your existing APIs as plugins without, you don't have to write any extra code for that, which is quite cool. So again, this is where you can do things in the real world by using plugins. Next up is planners. So planners is really like giving a user prompt, create a plan on how to actually accomplish the request. And by doing so, it can use 1 or more plugins. So this is the cool part of semantic kernel, because that's what allows me to say, I can ask it a question, and then it will figure out, how should I implement that question? How should I help the user? What plugins do I need to call? In which order? So that is really where the magic happens. And then finally, you have the persona. This is really, if you're talking about large language models, you have like this meta prompt or system prompt, which is where you kind of dictates how should the model behave, what is the persona, how should it respond, what should it be constrained to, and so on. So this is really important as well to get this right when you're implementing, user-facing applications. So I think this is an example from somewhere on Microsoft Learn, like an example for a retail company chatbot. So this is how a meta prompt could actually look. So very specific things about who the bot is or who the agent is. What role does it have? How should it respond? The format, but also like the behavior. What shouldn't it respond? It's very common also to include examples because that will make the model also respond better in the way that you want it to respond. So it's very, very common and very useful to include one or more examples. Like if the user asks this, you should respond like that. As you go along, you'll see that the model will respond much better in that case. Also defining things what it shouldn't do and things around like trying to minimize problems around safety and harmful content and those kind of things. And that's a big topic on its own, like responsible AI and so on. So I won't be covering that in this talk, but it is really important when you start building user-based or user-facing applications and you're using a large language model. So talking about plugins, so this is a prompt-based plugin, which is a YAML file. So this is not native code, so you can't really call things here, but you can, if you have a well-written prompt and you want to use that, you can just store that in a YAML file. So you don't need to hard code it in your code. You can store this, in a blob storage or in Cosmos or anywhere. Just load it up on demand. So let's talk about some of the important parts here. So first up, it's the template. That's the prompt itself. And in this case, I also have actually a parameter, as I showed you before. So this prompt says, generate a creative reason or excuse for the given event. Be creative, be funny, let your imagination run wild. And then it includes one example. So it's a plugin that will help me create an excuse, for my boss if I'm being late for something, for example. So that's the prompt itself, kind of. And then we have the description. And this is actually much more important than descriptions usually are. Because this is not just like a comment. This is what the AI model will actually use to decide, should I call this plugin or not? So this description is really important that you're write in a way that makes sense, what this plugin actually does, because the model will use this again to actually decide, should I call it, and what do I need to send to it. And that's actually the other part. In this case, I have a variable, so I also have a description for that variable. So the description of the plugin is turn a scenario into a creative or humorous excuse to send to your boss. And the variable is the event that an excuse needs to be generated for. So that's what the planner will figure out. Okay, I should call this plugin, and then I need to send the event that the user is referring to. And I'll show this example running in a few minutes. So that's for the prompt that you just want to store and reuse. But let's talk about native plugins. I can show you a C# example first. So again, this is when you want to do things like in the real world. And it's really, really easy actually in Semantic Kernel. So in this case, it's a super simple plugin. It's just a method that will do a square operation using the math library. And again, we have the description. And now this is just an attribute. So first up, we have the attribute kernel function. That's how Semantic Kernel will know that this is actually a method that I can use as a plugin. And then description, again, is used by the planner to figure out, should I call this plugin or not? And again, I have the description for the parameter as well. And then on the bottom here, all I need to do now is actually to import that plugin into my kernel. So now I have that inside my kernel, and the planner will now be able to call it. So very, very easy to do this. And again, like the math example here is, again, one of those cases where it makes sense to have those kind of plugins, because large language models, you can't trust them to do math. It will happily respond to any question you ask it, but it will most likely not be correct once it comes to math. So that's one of the good examples where you don't want to use the model. You want to use native code here, and math, that's a solved problem when it comes to implementing that in a computer language. So just as an example, this is what the same plugin would look like if you're doing this in Python, and you can also do this in Java if you want to. Any Python developers here? One. That's good. Then you came to the right talk. Okay, so now we have the plugins. Those are the things that will do something, but we need something to call it, and this is now the planners. So again, the goal of a planner is given a user prompt, create a plan on how to accomplish the request. And Semantic Kernel has multiple alternatives, but on the other hand, I have put most of them within parentheses because they are actually now, pretty much to be deprecated. So the reason is just that Semantic Kernel has been around for a while, and they implemented this planner functionality. So they have their own implementation of figuring out based on the plugins and based on the user query to build a plan, which can be quite cumbersome. So they have these implementations. But then a few, maybe it's, 1.5 years ago or 2 years ago, OpenAI released what's called a function calling, which means that these kind of decisions are now kind of built into the models. So the model has now built-in support for calling functions. So I'm going to explain how that works because that's really important to understand it for several reasons. So I'm actually going to just show you from the documentation on OpenAI how this actually works. So let's just go down to the documentation here. So this is like the OpenAI example of a function calling. So in this case, the example here, the user asks, okay, what's the weather in Boston right now? What's the weather like in Boston right now? So let's take a look at what actually happens when I do this, if I have a function or a plugin that needs to be called. So let me just zoom this a little bit up so you can see. So this is what happens when you do this. First, we make a request to the API. So let's start with this one. So that's the message that is being sent into the model with the role user and my question. But that's not the only thing I'm sending the model. I'm actually also sending this whole thing, the definition of my functions. So these are you can think of this as the plugins that I just talked about. So I'm telling the model, hey, I have a function. It's called getCurrentWeather. And it has a description and it has some parameters. In this case, it has one parameter, which is the location, where if the user asks about the weather in Boston, then Boston would be the location, right? So I'm sending it the query, and I'm sending it one or more functions that I have defined on my side. So let's look at the response then from the model. So first up, if you look down here, it says finish reason. So that's the reason why it finished and gave a response back. In this case, the reason is function call. And that means that the model has decided that in order to proceed, you need to make a function call based on the query and based on my functions. And then obviously it also tells me here that, what function should I call. So if you hear this about function calling and models, you might think that those functions are being called like in the cloud somewhere from the model. That's not what's happening. The model is used to reason about the request, reason about your functions, and decide what plugins needs to be called, in what order, and with which parameters. So it responds back to me now, says, you need to do a function call. You should call the function getCurrentWeather, and you should pass it the argument location, and the value should be Boston. So it kind of extracted that information from my query, right? So again, that's the response. So then I need to actually call the API. So in this case, they just say call your API, because this is now running like in your code, right? This could be this is in your environment. So you just need to call that function with the right parameters. So they just showing do a curl or something, but this could be really anything. And then that particular function, in this case, just responds with some information from some weather service. Okay, so now we have kind of the information here, but we haven't replied back to the user. Like the user asked a question in natural language. What is the weather like in Boston? So now we need to generate a response based on the facts that we just got from the plugin. So now we're doing another request to the API. And it's hard to fit everything here, but so now you can see that we're actually passing, again, the whole history. Always important to make the model reply as good as possible. So I'm sending the original question. I'm sending it the answer from the assistant. That was the reply back from the second run. and then I'm sending it. The last one is actually the results of my function calling, right? So I'm telling it now, I called the get current weather function, and this is what it replied, right? So now the model has the chat history, it has my question, but it also has information about that function response. And the response will now finally be, the weather in Boston is currently sunny with a temperature of 22 degrees Celsius, and the Finnish reason is stop, which means that now we're good to go. So based on my question, it actually could have replied back with another function call if I would have asked about something else, or it actually needed maybe to do 2 function calls in the same session. But in this case, it figured out that the query from the user has been answered. We can stop now. So this is important to realize when you're building plugins, what actually happens under the hood. It's also related to things like performance and cost, because as you saw, I'm passing it the information about my functions, which can be quite detailed. And what you're paying for with these models is the number of tokens that you're sending into the models and what you're getting back. So as you can imagine, if you have like 1,000 plugins with 10 parameters each, that's going to be a lot of tokens, right? So be careful, with that, and think about like the scope of your plugins and so on, because it could be both like potentially costly and also be a bit of a latency if you have too many plugins. So you need to be careful how many plugins you import here. So again, once you have the plugins that I just showed you, doing this, what I just showed you, that's a lot of code, right? If you would have implemented that yourself. You need to map, first you need to do all the calling that I just showed you. Then you also need to map the response JSON into actual function calling. You need to map the parameters, get the response back, map that again, and call the API. That's a lot of work. But with Semantic Kernel, the only thing you really need to do is that one line. Just say, hey, I want you to call my functions automatically if you find that necessary. And then I'm just importing the plugins that I want to use, and I'm asking it to query. That's all I need to do now to actually do that function calling. So this is really the implementation of a planner. It now uses the function calling of these models. So I can just import them, and then I can ask it questions, and it's going to call the plugins as it wants to. So let me show you an example of how this looks like. So let's start with just the plugins themselves. Let's do like this, and I can zoom a bit. So first up, let me show you the prompt plugins that I showed you from the slide. So this is one way of storing and running prompts, based in a YAML file. So let's open the YAML file again, so you can see what it looks like. So again, that's the format. That's exactly what I just showed you on the slide. So in this case, I'm storing it in a file. Again, I can store this in a blob storage somewhere. Or I could actually generate it on demand if I want to. But the point is, like, again, you will be working with these prompts to make to make them as good as possible and as precise as possible. And then you want to probably go on and reuse them and maybe parameterize them. So once I have this file, if I go back here, in this case, what I'm doing here is I'm just reading the YAML, and then I am creating a function. So there's a called create function from prompt YAML, which pretty much means that take this YAML file and import this and treat it as a plugin, right? So those are the three lines. Like take the YAML, import it into the kernel as a plugin. And then I can now explicitly, call this plugin. So in this case, I'm invoking the kernel. I can actually specifically say run this particular plugin and send it a topic. So in this case, I'm passing the event of a customer meeting, and then I want to have an excuse. So it says, I apologize for running late to our meeting, but I had an unexpected run-in with the League of Rogue Giraffes. They stormed into my live. Okay. So that's a very good excuse. So as you see in this case, I'm actually not using the planner functionality. I'm explicitly invoking that plugin, which might make sense sometimes. Maybe you don't always need a planner. Sometimes you just know what you want to do. Use this prompt or use that plugin. So I can invoke that plugin specifically like this. So we get into the planner soon, but I also want to show you this is actually also a possibility. So let's look at a native plugin instead then. So in this case, I have a plugin in C#. Let's take a look at this one. So it's a plugin that we'll call the Swedish Radio API. So again, I'm using the attributes here. The kernel function, that's what signals this is actually a plugin. Then I have the description, search episodes from Swedish Radio. Sorry, it's radio. That's not really necessary. That's the plugin description, and then I have the description of the parameter, which just says search query. And to be honest, that's actually quite a poor description. That's not really necessary because the parameter is called query. The model will figure out that it needs to send the query there. You don't really need to write that. That's actually some unnecessary tokens there. But in many cases, you need to add some information because just the name of the parameter won't be enough for the model to figure out properly. So in those cases, you want to be like specific. And then it runs some code, and it's not important here at all what this code actually does. Just do something, and it just replies. With in this case, it just replies of a list of Swedish radio episodes. So it replies with a list of types. So not really like specifically for semantic kernel or anything. I can just return this information as is. I don't need to do anything specific with it. I'm just returning that list. And this is just the class that contains the information. That's it. So if I run this now, let's go back to this one. So I'm going to invoke this plugin. I'm going to pass the value for the query as technique. So search for the episode that has to do something with the technique, and then it's going to write the episodes here. So let's run it, and we get a list out of episodes from the Swedish radio. So again, what I'm showing you now maybe seems like a very complicated way of defining and running code, right? Because I'm defining class and have attributes, and I'm doing invoke, and I'm calling that class. So that might seem like a cumbersome way of doing it, but again, the magic really happens now when you start using planners here. So let me show you an example of this then. So in this case now, I'm gonna import two plugins. First, the one that I just showed you, the Swedish radio plugin, but also I'm going to import a file plugin. So the file plugin can talk to the file system, read files, save files, and so on. So it's a very simple plugin. So I have two plugins now, and then I'm asking it this. So get a list of all programs about technology that has been aired today on Swedish Radio. List the programs with name, title, or URL, blah, blah, blah. Save the list of programs in a file called episode.txt. Then return the list of programs back to the user. So this is now the input to the semantic kernel. I'm not really saying anything about what it should do, how it should do it. I'm just asking it, this is what I want. I have passed it some plugins, right? So it knows that those will exist. So most likely it's going to use that when I run this thing. So let's run it and see what happens. So we already have a new file here called episodes.txt down here. You can see that it just popped up here. And now I also get the reply back, like before. So again, it lists all the episodes with the information. And down here, it also says now the list of program has also been saved in a file named episode.txt. So that's kind of cool, because now it actually went out to the internet, fetched the information, returned it back to me, but also saved it in a file called episode.txt. And it did that by me importing those two plugins and call them in the right way. That's really the basics of function calling and the planners in semantic kernel. And as you see, it's very, very easy to actually do this. And again, it's this parameter that I'm using here, the tool called behavior, that will automatically call the functions. Now, I don't have to use the auto invoke if I don't want to. I can actually also use kind of a manual invoke, because sometimes maybe I don't want it to automatically call my plugins depending on what the plugins do. So I can actually implement like a manual calling, but then you need to kind of loop loop the information. I can actually show you quickly what that looks like. Then it's going to be more code. So in this case, let me see if I find the option here. In this case, I'm just saying enable kernel functions, but don't call them automatically. So pretty much what happens is going to still return back, this is what you should call, but it won't call it. So then you need to call it. And then you need to write some code to actually loop through the calls and actually call it. So can anyone come up with a good reason why I want to do this?
So it's really expensive.
Can be really expensive. That's one case. Another one?
Human intervention.
Sorry?
Human intervention.
Yeah, human intervention. So depending again what the plugin does, maybe it's going to create an order somewhere. Maybe you want to have a human in the loop. You most likely want to. In that case, it can make a lot of sense to kind of pause it, ask for user approval. If I approve, then you actually make that call. So both of the options are possible here. All right, so we have plugins and we have planners. So I'm going to skip this one. This is one of the deprecated plans called handlebars. So I won't cover that today because what you want to use is the function calling anyway. So to build a Copilot, you kind of need these things that I talked about. You need to define the persona. You need a planner. You want the chat history, available, so it kind of had the context. And then you're going to write probably a few plugins, or many plugins, depending on what you wanted to do. So as an example of this, and what I showed you in the beginning of the presentation, a while back I built like our own Copilot internally, and connected it to various systems. So we're a consultancy company. So we have systems for time reporting. We have resource planning, who is doing what when. That's a big part of a consultancy business, to figure out what should I do, which customers should I work on this week and next week and so on. We have a system for booking rooms at the office. We have SharePoint like everyone else with the documentation. We have like CVs and solution documents and all this stuff. So this is the information that we need, and we have various systems for this. Like we have a UI for this, we have a UI for that. So I thought, like, why not build a Copilot instead of doing this? So expose this information in a chat-based interface. So let me go back to what I showed you initially, which is our Copilot. So if you look down here, it's a bit small here. You can see it just lists the plugins. So I've imported a few plugins. So again, this is like our resource planning, the room booking. We have the SharePoint. We have the math plugin that I talked about before. If I ask it a question related to math, I don't want the model to respond to that. We also have a Shelly, which is like a cloud API for have sensor information, which is like the first thing I implemented is like I could ask it what's the temperature at the office. It's just for fun and for demonstrational purposes. But let me just ask that question. So I can say, how hot is it at the office? Very important question. So it's going to respond back now with saying that. So we actually have 4 sensors in 4 different rooms at the office, which are called like that. So it responds back with the temperature at the office, right now. So I have a tab that shows, what's going on here. So what actually happens now is that for the Shelly plugin, I have 2 methods. One is get me all the sensors, and the other one is for a particular sensor, what's the temperature right now? So the model figure out, in order to respond to the questions, first I need to call, the get all sensors, like this. Oops. And then for each sensor, I need to call to get the temperature for that particular sensor. So it actually makes 5 calls there under the hood. So if I now ask it, for example, what's the average temperature? What do you think will happen now? Sorry? Will it make it needs the, in order to calculate we have a math function, so in order to calculate the average temperature, it's still going to need like the temperature, right? So the question is, will it call all these things again?
No.
No, it's a leading question, and why not?
Because it has context over what is already been done.
Exactly. So we still have the chat history. So if I ask it what's the average temperature, it shouldn't have to call like this plugins again because it already knows the temperature. So let's send it. And it replies back with the average temperature is 25.5 degrees. And you see to the right here, it actually did 2 calls. First to math summarize and then to math divide. So you can see the importance here of having the chat history, because if I would clear the chat and ask like, what's the average temperature at the office, then it's going to do all the calls again. That will take some time. It's going to cost you some money again. You will in the end get the same reply, but again, that could be deduced from the chat history. So that's cool, but it's not really like valuable information for me about the office temperature. But it's more relevant if I ask like, what's my plan for the week? So that's going to talk to our resource planning system. So it shows me that for this week, Monday, Tuesday, I'm assigned to the utbildning talare, which means I'm here at Setug talking. Tomorrow I have a thing with Microsoft, and then Thursday, Friday, I'm working at a customer. So you can see here again, like what it did, it called into active planning, which is our planning tool, and it responds back with the information about like what people are doing. And again, it's really simple because this is just an API. I pretty much just output like the raw information from that API. I don't really do anything with it. I just return a list with employees and what they're doing for the week, and based on that, the model can make this kind of qualified responses. So I guess the coolest thing is now, because this now becomes like a UI, instead of all those different UIs, I can use the chat-based interface. But what's really cool is when I combine information from multiple systems, then it becomes kind of an integration solution. So if I ask it this one, so ask it, find a room at 4 p.m. Maybe I should say like an available room. Find available room at 4 p.m. that is large enough for all the people working with Lania. So let's try this one and see what happens. Because now it needs like multiple information. First up, it needs to know what kind of rooms do we have available at the office and the availability status of those rooms. Then it needs to figure out how many people are working with the customer Lania and kind of figure out which rooms are big enough to handle those people, right? So now it says like, okay, the following employees are working with Lania today. So Helene, Fredrik, Ivar, and Johan back at the office, they're working with Lania, that's 4 people. And then it also figures out all the rooms that we have and says that, okay, there's 2 rooms available that is 4 people or more that is available at 4 p.m. So I think that kind of shows the power of the Copilots now, because I cannot only just talk to one system, I can talk to multiple systems in this very easy way. I can actually, implement or do user stories here that I didn't really think of like beforehand. Now we have the information available, and I can let the user ask questions about them, and the user knows what they want to do. I don't have to, implement that or figure out in the normal way before by defining user stories and implementing various UIs for this. So I think that's a pretty cool case here. So I think I'm 2 minutes left. Yep. So actually what I quickly want to do, maybe I will do that in 2 minutes. So that was Copilots, and I just want to show you like the last part of that trajectory when we go into the agent space. So we defined Copilots as this. We have the persona chat history. So it's like an application that sits next to the user. But when we're talking about agents, we will have multiple of these things. They won't have a UI, but they will still have a persona, chat history, and plugins. And they can be running on their own, and they can be communicating to each other, maybe like this. So there's various patterns here when you're implementing agents. So I just want to show you can implement this in Semantic Kernel as well. And just as a final demo, I will show you that. Thank you. So let's go to this one. So in this case, I'm defining 2 agents like this. And each agent will have an instruction, a name, and the kernel. And the instruction is really the prompt to that particular agent. So I have one agent for a software developer. The persona and one agent for a conference organizer persona, like Matthias. So let's look at the prompt here. So first up, we have the software developer instruction. There's a lot of text here, but it pretty much says that you are a software developer, you love to share your knowledge, and you're about to write the proposal for the Svetug developer conference. What we do. We send some suggestions of things that we want to talk about. And I give it some information like what the structure should be like, and some guided instruction here. You should be focused. If you get suggestions back, you should consider them, and so forth. And then the other agent is the organizer part. And then it says you're part of the organizer team for the Svetug developer conference, and you're in charge of kind of accepting proposals for talks to that conference. And then I give it those guidelines, like make sure the topic is relevant, is the proposal clear, it must. And then I have some contrived things here just for demonstrational purposes. I say that the proposal must not be longer than 100 words, and it has to contain the term AI overlords. And you'll see why. So let's run this, because now what I can do, I can just create what's called like a group chat, like this. So take those two agents, put them in a chat, and start them off with an initial query like write a proposal. So let's run this and see what happens. So it's going to take a few seconds. Come on. So what's going to happen now is you're going to see like a communication between these two agents. So I started off with an initial query or request, write a proposal with the following topic, developing AI agents with Semantic Kernel. So then the software developer picks this up and writes a proposal with the title, abstract, and an outline. So a bunch of text. Then the conference organizer here responds, this proposal does not contain the required term AI overlords, and it exceeds the word limit. Consider revising to meet the guidelines. So then it goes back to the software developer, which picks this up, consider the suggestions and writes a new one. And the organizer now says, this proposal is clear and concise, but it exceeds the 100-word limit for the abstract. So I think it did actually contain AI overlords now, but it was still too long. So it goes back to the software developer, it tries again. It still seems pretty long. Actually, maybe it was okay this time. So finally it ends here, it says, looks good to me. So it actually contained, it wasn't longer than 100 words, and it contained, the term AI overlords. That's a pretty cool way of implementing, functionality in terms of autonomous agents running around. And like this is really the imagination is really what's stopping you here. You could do anything, but also there's a lot of responsibility that you need to take before, performing actions. But you can see how you can build these things using Semantic Kernel. It's quite easy and quite fun as well, I would say. So with that, I have to end. Thank you very much for coming to the session. Have a nice conference.